Okay, so our formula for finding the vertical asymptotes is pi over 2b plus pi over bk. So this is pi over 2 times 1/6 plus pi over 1/6 k. Because a reminder, this is the same as the tangent of 1/6 theta. So let's see, this is pi over 2/6. So keep, change, flip. So that's 3 pi. So 3 pi plus keep, change, flip, pi times 6 over 1, 6 pi k. So if an angle, xy plane, the angle is in standard position, what is the slope? So 7 pi over 4. We know this is negative root 2. So this is pi over 4, root 2 over 2. So opposite over adjacent equals negative 1. So pi over 6. So if we look at pi over 6, here's pi over 6. So this is 1/2, and this is root 3 over 2. So 1/2 divided by root 3 over 2. Keep, change, and flip. So we have 1 over root 3, and if you rationalize that, we have root 3 over 3. So 3 pi over 2 is down here, so that's 0, negative 1. Tangent is y over x, so negative 1 over 0. We can't divide by 0, so it's undefined. And 4 pi over 3, so that's in this quadrant. Our reference angle is pi over 3. So negative root 3 over 2 and 1/2, negative. And if you divide that out, you should get root 3. Negative root 3 over 2 divided by negative 1/2. Okay, so this next trig function, let's find our vertical asymptotes. So pi over 2b plus pi over bk. Well, our b value is 1. So pi over 2, pi over 4, plus pi over 2k. But this has shifted to the left pi over 4. So it's normally here, right? But these have shifted this is pi over 2. Sorry, I messed up. B value is 1. So pi over 2 times 1 plus pi over 1k. So pi over 2 plus pi. So this is normally at pi over 2 plus another pi, 1, 2, 3, 4. But it's moved to the left pi over 4, so 1 tick mark. So 1, 2, 3, 4. 1, 2, 3, 4. And it's at negative 1. So here, and it's positive at the beginning. So we have those swoops. So here's our middle and swoop. Okay, so our next one, pi over 2b plus pi over bk. So b is 2, so pi over 4 plus pi over 2k. So pi over 4 would be here plus pi over 2. Okay, and there's no right left shift, so I can just dash this on in. Hold just 1 minute, okay? So I'm gonna keep dashing this in. It's at plus 3. So 1, 2, 3. But this negative in the beginning makes it a swoop going down. Okay, we can skip this part. We didn't really talk about this. We talked about the transformations.
Okay.
So if this was a transformation opposite x, so again, that's reflect over the y. That goes up, and out in front is a vertical. All right.
Is that unlocked your door? 'Cause my
Yeah,
computer's
it
not-
is. Okay, find the inverse of each function in the domain and range. So this is where we did f of x and our inverse. And domain and range. Well, we already know our domain, negative pi over 2. So that becomes our range. Negative pi over 2 is less than or equal to y. And think about what is our range. Well, our midline is negative 5, right? And up 2 and down 2. So negative 3 is less than y is less than or equal to negative 7. Oops. Small should go first. So that means our y value, or our inverse, it becomes the domain. All right, and then how do we find the inverse here? So we switch our x and y to the sign of y minus 5 plus 5. So x plus 5 equals 2 sine of y. Divide by 2. And then we have to do the inverse. So sine inverse, sine inverse. So the inverse sine of x plus 5 over 2 equals our y value. And then number 12, let's do some solving. So minus 5, 2 sine of theta equals negative 1. So our sine of theta equals negative half. Well, sine's our y value. So y is negative. What is opposite this? Would be pi over 6. And so that means in this quadrant, it's 7 pi over 6. And then we also have 11 pi over 6. Now, we can factor this next one. I can take out a cosine of theta. So this is the cosine of theta plus 1 equals 0. So for this to be true, either the cosine of theta equals 0 or the cosine of theta plus 1 equals 0. So where does our cosine equal 0? Well, that's pi over 2 and 3 pi over 2. And this would be, where does our cosine of theta equal negative 1? Well, that's our x value right over here is at pi. Now the next one says to find using our calculator. Okay, so if we were to solve this, minus 5, 5 sine squared of x equals 3. So sine squared of x equals 3/5. So the sine of x equals negative square root of 3 over 5. And then you'd have to do that inverse sign on your calculator to do that. So the inverse sign of those values. All right, this next one, it's a quadratic, so we can set it equal to 0. And then we can factor it, and I'm just going to do it with an x. So this is like x squared, negative 3x, negative 18. So it multiplies to 18 and adds to 3. So x minus 6 plus 3. So this factors into the tangent of x minus 6 and the tangent of x plus 3. So either the tangent of x equals positive 6 or the tangent of x equals negative 3. And then again, you can do that inverse tangent. Okay, evaluating the following. The secant is the inverse of the cosine. So cosine of pi over 3, root 3 over 2 is half. So if that's our cosine, the secant would be 2. 1 divided by 1/2. So this is 1 divided by the sine of negative pi over 2. So negative pi over 2 is here, 0, negative 1. So that'd be 1 divided by negative 1 is negative 1. So this is 1 over the tangent of 5 pi over 6. So pi over 6, 1/2, negative root 3 over 2. So our tangent, opposite over adjacent. And I know that simplifies to this. So 1 over negative root 3. 1 times negative root 3 over 1 is negative root 3. The next ones you could type in on your calculator. And then we have a couple graphing ones. So what is our midline if we were to graph the sine? Midline is negative 1, up 2, down 2. And then what happens, it's a sine, starts in the middle, but it moved to the left pi over 2. So it's really here, 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 So there is our sine graph, but remember we want cosecant. So vertical asymptotes go through the middle. So middle, 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 middle. And remember, then we turn it. So our graph is the one that is in red. So our range from negative infinity to negative 2, and then from 1 to infinity. And it includes those values. And our vertical asymptotes are at pi over 2 plus every pi n. So secant is our cosine. So midline and up 3 and down 3. Our period, 2 pi divided by half, is 4 pi. So cosine starts high, right? And then it would go mid, but it's 4 pi. So a complete cycle there. It's gonna stretch it out. So it's going to go from low to low, because that's 4 pi. So mid, mid. Put our vertical asymptotes in the middle, and then we flip it. So our range from negative infinity to negative 3, and then again from 3 to infinity. And our vertical asymptotes start at pi, and then it's every 2 pi n. All right, now on to some trig identities here. So rewrite as a single trig identity. So we can start by rewriting a sine and cosine. So we're left with just the cosine of x. Now, as soon as I see that squared, I start thinking of that Pythagorean identity. So 1 minus the sine squared, this whole thing is cosine squared, times 1 over the sine squared of x. So that's cos squared of x over sine squared of x, which as a single identity is the tangent squared. All right, and now I see this, cotangent. Again, I'm reminded of this one. And I need cotangent, so that's cosine over sine. So if I divided this whole thing by sine squared of x, I come up with another identity. 1 plus the cotangent squared of x equals the cosecant squared of x. So I have 1 over the cosecant squared of x. So 1 over the sine squared of x. 1 times sine squared of x over 1. So that's the sine squared of x. And now we have the sum and difference. So this is a sine. So I go to that formula sheet, and this is the sine of alpha cosine beta minus the sine of beta cosine of alpha. Okay, so I have 3 pi over 4. So root 2 over 2, negative root 2 over 2. So there's the alpha. Beta is 5 pi over 6. So that's pi over 6, 1/2, negative root 3 over 2. So sine of alpha, root 2 over 2 times the cosine of beta, the x, negative root 3 over 2. Sine of beta, root 2 over 2, cosine of, nope, sorry. Did the wrong one there. So sine of beta, so that's over here, is 1/2. Cosine of alpha, negative root 2 over 2. So this is negative root 6 over 4 plus root 2 over 4. So negative root 6 plus root 2 over 4. So this is a cosine one. So again, look at your formulas. Cosine. So cosine is cosine of alpha, cosine beta, minus sine alpha, sine beta. So we got pi over 2, 0, 1. 2 pi over 3, 3 over 2, and negative 1/2. So alpha and beta. Cosine alpha 0, cosine beta, the x value, -½ sine alpha, 1, sine beta, √3/2. So this one is just -√3/2. Then the last thing, polar coordinates. So plot this. So I look at 2 pi over 3. I'm standing in the center and I walk backwards 3. 1, 2, 3. Convert from rectangular, polar to rectangular. So r theta to xy. So x equals r cosine of theta. Y equals r times the sine of theta. So 4 cosine 5 pi over 6 for the sine of 5 pi over 6. So here's 5 pi over 6, our reference angle of pi over 6. So half -√3/2. So we have 4 times -√3/2. 4 times half. Well, 4 and 2 reduce down, so we have -2√3 and 2. So rectangular to polar. So if I was to graph this, 2, -4. Here's our radius. So -4 squared plus 2 squared equals r squared. So that's 20. So r equals the square root of 20, and we need this angle. So the tangent of theta, -4/2. So the tangent of theta equals -2. And then we have to use our calculator to figure out what our theta is. So we have the square root of 20, and then whatever our calculator tells us. Convert from rectangular to complex polar. So we're asked to go from r cosine of theta, I sine of theta. So same thing, I'm going to graph this. -3, -5, our radius. -3 squared plus -5 squared. So 25 plus 9 is 34. So we got the square root of 34, and then our angle. So the tangent of theta. And again, you'd have to use your calculator to figure out what the inverse tangent of -3/5 is. And then we plug it in, the square root of 34, cosine of our angle, plus I sine of that angle. And then converting from polar to rectangular. So we need to get to A plus BI. Well, this one's nice, we can just evaluate it. So here's 3 pi over 4. So we have 6, the cosine of 3 pi over 4, -√2/2, plus I, the sine, +√2/2. And then we just distribute. So -3√2 plus 3√2i. Okay, and then let's do some matching. All right. So I know radius equals 6. That's an easy one. Which one just has a circle with 6? Letter D. Let's see, what else looks like another one? This is just a line, so that's K. This is a circle to the left, so that's a cosine circle. And it's got to be negative cosine. Or does that have a dent in it? Oh, well, I know this is a rose one, right? And it's got to have 3 petals. And goes out to 6. So this one has to be L. Wait, this is it, sorry. Because it's along the y-axis right here. This is a letter B, has got to be a cosine rows. And negative, so that would be letter B. We didn't talk about which one this spiral one is. So I'm going to tell you right now, this one's H. We did not talk about that one at all. Here's a rose, how many petals? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that has to be one, and it looks like it's cosine, but that's when it doubles. So that number of petals has to be 6. So that would be when it's even, and oh, I guess it's symmetric to the y-axis. So the first one doesn't start here. And these are tough. You could probably, you know, I'm going to tell you, you could use your calculator for that link. We're not going to worry too much about the matching. So let's see if they have any other ones. Because this will focus more on the multiple choice ones that we did before. So is f increasing or decreasing on this interval from 0 to pi over 2? So let's take a look at this next one. Is the distance between the pole increasing or decreasing from 0 to pi over 4? Well, the distance, -5 to 0, it's definitely decreasing. Now, is the function increasing or decreasing? Let's come back to this one. We didn't talk much about that one. Find the average rate of change. So we could do f of pi over 8 minus f of 3 pi over 8 over pi over 8 minus 3 pi over 8. So that's slope. So negative 0.4619 minus negative 1.913 over, that'd be negative 2 pi over 8, and you could use your calculator. So find the average rate of change. We can skip that one as well. And then there's a multiple choice one. For what here's an equation. For what values of x is f of x less than 1? So we're setting this up as less than or equal to -1. So if we solve this, so that's -1/2. So we know our sine is -1/2. So that's pi over 6. So this is 7 pi over 6 and 11 pi over 6. And we want to know when it's less. Well, it's less down here, right? Our y values would be less. So that is letter A.